Good evening, ladies and gentlemen. I am Riya Modi, and it gives me immense pleasure to extend to you a very warm welcome on the behalf of the Department of Biomedical Engineering and Team Impulse. I would like to welcome our conveners, dignitaries, and faculty members and thank them for virtually joining us today. Your guidance has always geared up our spirits and enthusiasm. Department of Biomedical Engineering has two committees under it, Biomedical Student Association BMSA and Biomedical Engineering Society of India BMESI. Our goal is to furnish a community for students in biomedical engineering in both a social and professional way. Today we are here to hello.
Yes, you're audible, Ria. Go ahead.
The mission is to foster effective academic, community and professional collaboration between students, faculties, business leaders and other committees. So now moving on towards today's hands-on workshop, Data Exploration with Orange. Advances in automation and artificial intelligence, while increasing productivity, will also cause major upheavals to the workforce. Are the concepts of artificial intelligence, machine learning, deep learning very difficult? Do you all think so? To simplify these concepts, we can use graphical programming techniques. Orange is a software that manages data with inbuilt graphical functions and makes the work easy. Want to know how? And want to create a project with it? Here we have a hands-on workshop on data exploration with Orange. But before we begin, here is an important announcement for you all. We had earlier shared a drive link that contained instructions to download Orange software and two different data sets. I have reshared the same link in the chat section so that you all can equip yourself with the necessary materials for the workshop. Now moving on, I would like to welcome among us our spectacular, super talented speaker, Mr. Khan Mohammed Saqiful Alam. He is a program manager for Trust and Safety, Southeast Asia at TikTok, Singapore. Along with this, Mr. Khan is a Tableau certified associate. He aims to impact human lives through research and strategy, analytics and behavior studies. Not only this, he is also working tirelessly to help the younger minds around the world, teaching, consultation, and for creating better opportunities. At present, he is also pursuing a PhD in strategy and policy in National University of Singapore. Besides this, advising a big data startup in Bangladesh. Mr. Khan is working as a strategic partner with another consultancy company in Bangladesh. In addition to his vast array of experiences, he is working together with Google Business Groups Singapore. Our speaker has published in several international and local journals in social business models and decision models and has also contributed to the national newspapers. We are blessed to have your committed presence, sir, and we would like to hear from you. The platform is all yours.
Hi, Ria, and hi, everyone. I hope you can hear me clearly, and there is
Yes.
not much background noise. So, thank you so much for the invitation, and actually, sorry for rescheduling this session once already. I had to go through a little bit of an urgent surgery last week. And thank you so much for the nice introduction. So, before we start, let me actually give you some backgrounds of what Orange is or how we came to use it. So normally in the field of data, one of the biggest challenges is say whenever someone enters the field of data, one of the biggest blocks people find is coding, and especially I think one key problem with coding is that for us who are young professionals or just starting off universities, it's fine, we can always pick up new skills very fast. But what becomes difficult is for established professionals, especially say people who might not think of data science or data analytics as the main career, but would also like to use data to do some basic explorations, or even people who are questioning themselves that should they enter this field. So for people who are starting, people who are a little intimidated to start with coding, I think this tool, Orange Machine Learning, is a boon, a very useful thing. So I got introduced to it when I was starting my journey in National University of Singapore. So besides working as a researcher, one of the things that I do is I work with NUS to train corporates, and we get corporates from both Singapore and from outside Singapore as well. So for example, last year, it was a very big pleasure to meet the Tata Group. So we were training the mid management and senior management on sustainability for the Tata Group. So one of the trainings for corporates I take is basically about analytics, like how businesses can be driven by analytics, how decisions can be driven by data. So from that perspective, it would have been very useful if I could train my participants in, say, R or Python. But one of the limitations is that a lot of times my participants are mid-management or even people who are early in the data career. So for them, for a 3-day workshop to start with R or Python is a little daunting. And which is where I think like we were looking into potentially tools that are basically GUI, graphical user interfaces, on top of Python. And that's where we landed on Orange Machine Learning. And it turned out to be, it's a software that started quite some time back, but now it's gaining critical mass. I know quite a lot of people, and I know for certain that, you know, few companies in Singapore are actually using this software right now because it can do quite a lot of stuff, which you can, like, you know, without learning to code. So today I'm gonna talk about that software and what you can do with that software. So let me first introduce the place where you can download Orange from. So if I can share my screen to start with. So I'll be sharing my main screen because I'll be jumping around from windows. So do excuse me from like if just the team window pops up as first. Oh no, the Orange window pops up at first. So first of all, if I show you the website where you can get Orange from. This is the website, orangedataMining.com. And the reason I'm showing this data, like, you know, website is because only like besides just downloading the software, I think this tab has been very useful. So when you get an idea about how to use Orange, you can actually do many workflows such as Twitter data analysis, text classification, text clustering. Then it could be like, you know, cross validation, training and test data, feature ranking. So they have like, you know, many use cases as cases here. So this is one very useful place to explore. The other place that I always explore is blogs, where people who are pretty much into using Orange can share many things using like what they have done using Orange. For example, this one was a pretty good one, which showed that, you know, how we can do AI project meeting, explainable AI project meetings using Orange. So quite a lot of interesting stuff here. But now you can always download the software for free, which is another reason why we are like we suggest our participants, and we like I personally champion Orange because of this, is because today we live in a world where I would not want to pay too much for software because I mean everything is open source. Like Python is open source, R is open source. And the beauty of open source is that it builds up a library of resources very fast. So from that perspective, Orange Data Mining is a free software for either Linux, Mac, or Windows, and it works fluently in either of the operating systems. I personally have tested the Windows and the Mac one. The Linux one I haven't had the chance of exploring, but you can check that out as well. They also have something called Portable Orange. This is mostly for tablets or a few other soft, like, you know, platforms where there are no installation files, and if you download this zip and unzip it and copy this folder, it works from any place the folder is. So quite easy and straightforward to get started with Orange. Now, besides this, you can actually also search in YouTube in terms of like, you know, Orange ML or Orange data mining tutorials, and they do have a channel in YouTube, and you can follow the channel. And I think it's in the workshops or the docs place. So you can see this is the one, the YouTube tutorials. So you can go through these YouTube tutorials. These are like, very bite-sized tutorials. Sorry about that. So very bite-sized tutorials on what you can do with Orange. And this is again by the company which brought you Orange. So I strongly recommend anyone who likes the software and is planning to work with it in the future to check this out. So that's about the website itself. Now, when you download and install Orange, your software would look like this. This is the GUI or the IDE for Orange. So you have a canvas here. This is where we will draw, or we will actually, use different functionalities from Orange. And then in the left-hand side, we have the widgets. So the widgets are the tools that we're going to use to explore the data, to do basic machine learning with the data. They are divided into a few groups. The first one is about loading the data and managing the data. So that is basically, cleaning, looking at basic, basic explorations, querying data, looking for specific groups, subgroups within data, checking for outliers. All these things is the data tab. Then besides data tab, we have the visualization tab, which we will see today to build some basic visualizations. Then hopefully tomorrow we'll look into some modeling in terms of how to build some basic models like supervised model, unsupervised model, how do we evaluate the models, and also look into how we can tackle text with Orange. Orange is actually pretty useful and something we use, I use a lot in my daily work for text, quick text analytics. So that's about the software. Now, before we start with the data or anything, I would like to also impress upon you, how useful these skills can be. So today, we live in the age of data. I know that I come from a different industry. I come from the business industry. My education mostly has been in business. And initially, when Ria reached out to me, I was telling her that my examples could be a little business-sided, and she was thankfully okay with that. But I think today we live in a world where data is everywhere. So even in biostatistics, if you look at it, in physics, in astrophysics, because I see a lot, I actually mentor someone who's an astrophysicist in training who looks for star clusters using data, and he actually gets some, I mentor him on a monthly basis. Now, it's in medical sciences a lot, the whole work of COVID and the whole situation with COVID relied a lot on data. So one of the few things that as data analysts anywhere in the industry we need to pick up, and which I see is a very important skill, or actually when I am also sometimes I interview people applying for TikTok. So in the data strategy or the data teams, so one of the skills that I look for as well, we look for, is how you can simply get some insights out of data. Now, sounds easy, but at the same time, it can actually be a little difficult, because in my experience so far, I've seen many people who can write up a very good code, who can run very fancy analytics. But one of the challenges that I've seen again and again and again and again is the ability to tell a story with data, to bring in some data, to quickly tell me what is an interesting pattern out of the data, what is an interesting story that the data is telling. I've seen many data scientists, many data analysts out there who would run a complex neural network the moment they get a data. But in reality, we go against it. We tell people that instead of running a very complex code to start with, first maybe a simple summary statistics can tell you so much about the data that you have in hand. So with that advice in mind, let's start with loading some data. But before even loading the data, I'll start with opening the data file. So I noticed that I made a small mistake, and I noticed that a little too late. So I'll apologize for that. the file I shared with you was the Microsoft Excel workbook. Now, unfortunately, Orange can't import from Excel workbooks. So we need to convert it into Microsoft CSV format. It's very easily done if I show you here that if we can open the workbook that I've shared with you and just have a save as, and we can just choose it to be CSV UTF format, so a comma separated variable. When we do that and when we press save, so I already converted it, so it's asking me to replace it, and I would replace it. So please take some time to do that, because I mean, to load the data on Orange, we would need it to be in CSV format. But now let's actually explore this data set first by just looking at the data. So this was another very interesting advice I got when I was working in an MIT project. So the professor I was working for, so he told me that, you know, the most important step in analytics is the least technical one. By that, he meant that the first step that you should do with the data is get a sample of data and first read that data. So what do you mean by reading that data? Reading the first two lines of data. The first line, most of the time, is the name of the columns. So if I look at this data, so unfortunately, this is again a marketing data we have, actually a sales data. So in this sales data, the first line is the column names. So the first one is cus ID is the ID of a customer, which is randomly generated. Then we have the age group of the customer. So before I give you more insights into this data, let me tell you how I got this data. So this data is actually from one of my consulting experiences. So it was a shop in US where we were looking into like a simple grocery shop in US where we were looking into purchases of customers. So unfortunately, I can't name the company because of NDAs, and I haven't shared with you the full data set. I've taken a sample, a representative sample of 1,000 customer purchases for each customer and gathered them into this file. So the first column, the column B, age, talks about the age group of the customer. Now, this is where understanding where the data is coded or how the data has come from is very important. So if you see, there are three age groups here: young, middle, and old. Young is basically people below 25. Middle was people from 25 to 40, and old were people, sorry, 25 to 50, and old were 50 and above. So that's how the age is coded here. Then we have gender, which chosen to be a dichotomous gender of male and female. Then we have whether the customer owns a home or not, whether it's own home or rent. Then the data is about whether the customer is single or married. Then we have the location, which is how close or far from the shop the customer is. Now, this was a personally identifiable information, which means that, you know, initially it was not location. Initially, the data was address. Unfortunately, address also have zip codes and personal identifiers through which you can find out the person. So for privacy, it was recoded, and this data file that I've showed with you has this as location, which is like, you know, either far or close. Then there is the yearly salary of the customer, followed by the number of children they have, how regular they have come to this shop. So the history talks about high, medium, and low, which is like, you know, the monthly visit. So it's high if the monthly visit is 5+. That is, if the customer comes 5 or more, then it's high. Medium is if the monthly visit is 2 to 5, so 2 to 4. And finally, low is when the monthly visit is 1 or less. Then we're looking into the catalogs, which is like, you know, the number of SMS marketing or email marketing catalogs sent to the customer over a month's period. Then the amount spent is the spending amount per month. And the last date of visit is a generated data. So because we could not share with you the original data, and it shows when approximately which time each of these customers have come to the shop. So this is actually one of the first steps of tackling any data. That is, going through and understanding where each of these data columns are coming from and what are they telling us. The second step is very similar to the first step. It's just reading the first row of the data, that who this person is. So this is an old lady who has her own home, is single. Now this is where one concern might come. So this is actually coded in a way that anyone who's not married is termed as single. So which means that she could be widowed, divorced, living separately, or single. Then we have the location, that is she is not close to the shop. Her yearly salary in USD is 47,500. No children. Comes quite regularly to the shop. Has gotten 6 catalogs in the last month, and her last month's full spending was $733 in that shop. And the last time she came was on 24th June 2016. So this step, actually, we consider this step to be one of the most important steps, is because when you go through this line and understand what the data set is talking about, this gives you an idea that whether you understand the data or not. Because again, in the via field of applied data, one of the things we keep on saying is that if you torture a data set enough, it will speak. But will that be worth the speak or not? That's a big question. That is why, instead of running too much analysis in the data, the first and most important step is just reading through the data. So now that we have gone through like the columns of the data set, as well as what like single row looks like, we're ready to start working on loading this data to Orange. By the way, I have a bad tendency of talking a little too fast at times. So if you're missing out something, or if there is a question that's in your mind, please drop a line and I'll be more than happy to answer your question. Or even feel free to unmute yourself and just ask. I'm perfectly fine with that, because you're putting in your extra times to try to understand this. So why not make the best use out of it, right? So moving to the software. So this is the Orange IDE, and here the way to load a data is very simple. There is 3 options here, as you can see. One is file, which is like loading an Orange data file. So Orange, when you load the data in Orange, you can save the data in the Orange format, which makes it easier to load again and again and again, which is called the dot data table format. Now the other formats you can load is the CSV format and the dataset format. Now the dataset format is like connecting it to a database. So you can load the data from any online repository. The same with the fourth option is the SQL table. And again, you can actually connect with an online SQL table, or you can actually upload a offline SQL table as well. So for us, we're going to stick with loading a CSV file. And this is how we start a flow. So we will draw our flow here, put in different steps, connect them, and do our work. So when we put this point here, we need to double click to decide which file you want to import. So from here, we go to browse the file system. And if I go to the place where I kept this file, this is the CSV file that I'm planning to load. So double clicking here would show me the file load panel. So here I'm offered few options of loading this table. So the first is it has automatically guessed that the coding is UTF-8 and it's a comma separated variable. So the comma separator is here. Now I could just choose which columns to load and which I don't need to work with. So first of all, I don't think the customer ID is a column that will give me any information, because it's just randomly generated ID numbers. So let's right click and choose to ignore this column. Now when right clicking, you see that there are a few other options: numeric, categorical, text, or date time. What does that mean? That means that when loading this file, I can actually tell Orange what type of data each of these columns will be. quite an important thing and quite a manual or a lengthy thing, but a good thing to invest your time in. Why? Because if you define a data set well, then the rest of the steps will be very easy to follow. So to start with, I don't want to take in customer ID, nothing that's very useful. Now, the age group. So the moment I move to the age group, you see that this has been red crossed out, which means like we're not loading this column. Now, age is not numeric here because it's divided into three groups. It's either categorical or text. So let me explain a little bit between the difference between the text and categorical. Text is just plain text, such as say a user's comment on how the website is, or someone's comment on a product, or someone's answer to an interview question. That's a text. That is a collection of letters into words, into sentences. That's text. And that could vary from every single row. Whereas category are text data, which are used as groups. So for example, for our age column, the old, middle, and young, these are old is a group where we are putting in everyone who's aged 50 and above. Middle is a group where we're putting in anyone between 25 to 50. Young is a group where we're putting in anyone who's below 25. So when we use a text as a grouping variable, we term it as categorical variable. So age would be a categorical variable. If we have the name of each of the customers, that would be a text variable. By that way, gender is also a categorical variable, own home a categorical variable, marital status a categorical variable, location a categorical variable, salary is not a grouping variable, it is a numeric variable, so we choose numeric. Now this is interesting here, children. Children normally, if you look at the number of children people have, it's numeric, but it doesn't follow a numeric function in this variable, right? I mean, for a numeric data, if we summarize a numeric data, we will get information on what is the maximum number of children you have, what is the minimum number of children you have, which is okay. But then the next step is if you look at the average children. What do you mean by average children? What if the average children comes out to be 0.8? That means on average, every family has almost a child. No, it doesn't make sense at that point. Children's then number of houses, number of cars are numeric data, but technically acts as a grouping variable. Because rather, I would like to know how many customers have no children, how many customers have one children, how many customers have two children, how many customers have three children, just like how many customers are old age group, how many customers are middle age group. So these numbers are not acting like a numeric function, but rather as a categorical function. So we choose this as categorical. The next one is history, definitely categorical. Catalogs is numeric. Amount spent is numeric. And last data visit is date time. So I understand that if you have a data set with 20, 25, 30, or even 100 columns, this exercise could take a lot of your valuable time. But I think it's something that's worth investing in, because when you set it up, first of all, you also go through that mental exercise of thinking, what is the function of each of these columns? And that gives you a good clarity of how you can use each of these columns in your analysis. Plus, you defining it once means that every next time, so orange, when you define it like this, orange will store this information in its repositories. So then the next time you load this data, you don't need to redefine that data set again. That's a very useful function in orange. Now, when we press OK, you see that there is saying there's an information saying 1000 rows, 11 features, 0 methods. And this 1000 means that you did something which led to 1000 data points being output from this first step, which is the CSV file import step. From here, we can look into what data we have loaded. So we can bring in data info and connect the CSV file to data info. Now what happens is this is what we call a data flow, where the data after loading moves through a flow to the next step, which is getting the data info. So this is the data info, which is very simple, straightforward, which shows me that there are 1000 rows, 11 columns. We haven't yet described any target that we want to predict, but we have described that there are 7 new categorical variables, there are 4 numeric variables, and the data is stored in the memory. So a basic description of the data set we have. Now, a better description is if we want to see what is the summary statistics of the data set we have, we bring in this function called feature statistics. So the feature statistics does the summary statistics of all the columns in the data that we have loaded. So when this is done, this is connected. We can double click this and see the summary statistics. So for example, if you see, it shows me the distribution of salary, which sort of looks like a log normal distribution, not a normal distribution itself, with an average salary, yearly salary of 56,000, median of 53,000. So a very good good quick analysis we can do with this is the mean and the median is pretty close to each other. So that means the data is not heavily skewed. Now the dispersion is this, the minimum yearly salary is this, the maximum salary is this, and there is no missing data here. Similarly, we have catalogs and spending amount. In terms of spending amount, for example, the minimum spending amount has been $38 in a month, whereas the maximum spending amount has been $6,217 in a month. The mean is 1200, the median is 962, which shows that this data is a little skewed because the median is much less than the mean, which also means that there are some people in the data, which I can guess for now. We will be able to zero down on them very soon, but we can guess for now that some people in the data are spending a lot of money, which has shifted the mean a little bit on the right side of the median. So there are some positive outliers in the data. Then if we look at the categorical variables, like the age, this is the age distribution. And so for the categorical variables, this is not really a very good way of summarizing the categorical variables. We need to do a better job there, and we will do that very soon. So, but for numeric variables, this feature statistics is a very quick way to find out what the data we have. So I'm going to pause a little bit now and check on you that any questions so far, any questions, confusions, any problems to follow me so far. Feel free to carry out these steps the way I'm doing it here, step by step. But if you have any questions, feel free to drop a question and I'll be more than happy to try and answer. If not, let's move to the next things that we can do. Besides just looking into the summary statistics, we can also look into the overall data itself. So now I've shown you one way to create these flows. Let me show you another way. So just from the imported data, we can just drag in a line in our empty space, and then let go of the mouse. So here it's going to give you an option of what you want to do, which function you want to run next. So what I want to run next is I want to see the data table. So when I give this option and when we double click, so here you see the data just the way we saw it in Excel. You see that the ID is not taken in because we have not loaded the ID data, but everything else has been loaded here. And one useful thing is you can visualize numeric values, which gives you a small line in terms of compared to the total data set, how big is this number, or compared to the total data set, how small is this number. So yeah, but nothing that fancy, just checking the data set. Now, things that we can do with this data. So one is we can actually quickly create the pivot tables the way we can do it in Excel. So let's actually clean this up a little bit. Say I don't want to know the data info. This is information, but let's put it here. Let's take it here, and let's bring in the pivot tables here and connect it with the data. Now, it starts with a basic guess of the pivot table. So it doesn't give you an empty place. So what is it giving you? So in the rows, we have age, and the values, we have age as well. This columns is the same as rows, and it's showing, like, how many people in each of the age groups. Not that useful. Let's choose in columns history. So this now shows, like, there are 167 people who are in the middle age group, high history, and then there is 127 medium history and middle age group. So now if I see for each of the age groups which history dominates. So for, say, the middle age group, it's actually the high and the medium histories that dominate. For the old age group, it's mostly the high history that dominates. For the young age group, is the other way around, is the low history that dominates. So just very simple count check about a pivot table. We can just see some insights here. Now, what we can do is also, instead of values, if we want to see that, say, okay, based on age and, say, gender, the spending of people. So say amount spent, and instead of, say, count of amount spent, I'm going to see the average spending amount. Now let's see what we get. So we have spending amount here. So it tells me that for the middle age group, the total average spending amount has been 1,500, old 1,400, and young drastically small. Now for the middle age group, who contributes most to the spending amount? On average, it's the male middle age group. For the old age group, it's still the male who contributes most to the spending amount. For the young age group, it's still the male. But you can see the drastic difference between the average spending of these two. We can also look into, besides the mean, we can also look into the minimum and the maximum spend of each of these age groups, just to see. So it shows that the drastically minimum spendings are again focused on the young age group. So very simple, very easy way to build these pivot tables. Now, what else can we do? So we have column aggregates. So what does aggregate columns do? So here we can see that we can create a column which is the total salary, average salary. So say, for example, I want to choose amount spent, and say I want to say that, okay, let's call this an average, so mean, and say let's create a new column which is called mean salary. Now when we do that, we would have created a new column. So if you look at this data set now, besides the amount spent, we now have the mean salary. But what's happening here is that the aggregation is the exact value, because when we aggregated the column, we just aggregated based on a single numeric value. So aggregation comes in handy when, say, we are merging different data sets, and then from each data set we want to aggregate based on different columns. So another useful function compared to the aggregate, so that works better than aggregate, is actually the group by function, which we bring in here. And if we decide to group by, now this becomes very useful. So let's say we want to group by age, and then we want to group by, say, spending amount, and we want to create the mean spending. So then what's going to happen is, if we look at the data table now, so we have the mean spending, mean salary, based on each of these age groups. Now, if I want to expand this a little bit, say we want to group by not only age, let's say we want to group by age, gender, married, and location. And then look at the data table. And this is another very useful thing in Orange, is that these things are happening real time. So when this group by is here, I can just open this data table and see what's happening. So now each of these groups, the first group is, if you look at this group, it's middle-aged group. And then, so let's expand this column a little bit easier. So first of all, it's middle-aged, female, own, married, close. And then, so this is like middle, female, married, close. So for this group, the salary is this, average salary. The mean catalogs is this, the mean amount spent is this, and the data visit is here. So we can do a little bit more as well. Let's look into group by, and let's say, let's not concatenate few stuff. So let's say, let's look at mean. Let's also look at standard deviation, and let's also look at the median, say. Now, if we see the data table now, oops, sorry. So the data table is at the background here. Yeah. So now we have salary means, then the amount, like salary mean, catalog, amount spent, median, amount spent, mean, median. So here is amount spent mean, the amount spent median. Then we have amount spent standard deviation. Then we get catalogs mean. So we can choose the different aggregations we want based on group by. We can choose the variable, visualize the numbers again, and that's how we can do some simple group bys. So this is another way we can present summarized information. So these are basic summaries that we can do with Orange. But now we can actually do a little bit more. There are some very useful functions, such as we can do something called select rows. This is one very useful thing about querying data in Orange. So when we bring in this select rows, we can actually create subgroups out of the data. So let's say we select rows like this. Say we want to find out. So let's say we want to do a query here. We want to find out all those customers who are in the middle age group, earning less than 50,000 USD a month, a year, spending around 2,000 or more in my shop, and who also own a home. So age group is, say, I'm saying middle. Then let's add another condition, which is like, who own a home, then who spent around, so is, let's say, at least 2,000. Now, as you see, the moment I'm entering one and more conditions, this field is getting smaller. So let's say when I added the age condition, so if I start with this, when I added age condition, it showed that there are 1,000 coming in, 508 coming out, which means that, the output is 508. So 508 people are from the middle age group out of the 1,000. Now, when I'm adding another condition, which is like, own home, is that they own their home. So that's 325 people. So out of 1,000, 325 are middle age and own their home. Okay. Now, when I'm saying that their salary is, say, less than, so at most 50,000, 44 people, and say then we add spending. So let's say amount spent is at least 2,000. That's 2 people. Okay, that's kind of restrictive. Let's actually increase the yearly salary. Let's make it 75,000. That's 18 people. So this is how we can actually add many layers of queries to narrow down on a smaller data set. Now, if we want to see this data set, we call it a data table. And if we look at this data table, we see these people who met our criteria. The people who are of middle age, who own a home, who are having a salary of 75,000 or less, and spending at least 2,000. Now, this is where something very interesting comes up, is that we can create subgroups of data. So let's say this is one group, the select rows. We call them, say, we can rename this. So right click and rename. So we can name them as, say, or let's call it actually medium income by high spend. Oh, there is a character limitation. Okay. Medium ink, high sun. Sorry, high spend. Let's say this is one group. Let's create another group. Let's go for select rows, and from here, let's say let's pick up next group is say people who are not of age. Let's not have an age condition now. Let's create a condition which is like, okay, females. I'm sorry, females with say living close by and who spend at least 3,000. So there are eight people in this group. So we can visualize them, or we can see them here in the data table as well. Here, these are the 8 people who live close by, who spend around, and who are female and spend at least $2,000. So their spending is at least $3,000. Okay. Now, what if I want to know whether there are people common among the two groups? Actually, to make the chance of things being common a little higher, let's increase the, that's 32 better. So let's say, let's rename this as M, close, and high spend. Now, I'll jump to one more widget here, which is the visualize, and here, the Venn diagram. It's nothing but just a Venn diagram. So we can create a Venn diagram between the two groups. We have one group of people here, one group of people here, and I just want to see what are the commonalities among the two groups. So we can create multiple arrows out of a space. So say I'm connecting this here. I'm connecting this here. The two groups are here. And now if I look at the Venn diagram, this actually shows that, okay, there are two people who fall under the same two segments, both A and B. So which is A and which is B? Normally what happens is if I double click here, so this, the first one is A, the second one is B. So the first A is basically the medium income high spend group, and this is like, you know, female close high spend group. So out of them, the commons are here. These are the two people who are common. These are 30 in group B, and this is 16 in group A, and these are the common ones. So if we want to visualize these people, the way to do so is we can look at the data and open something called the data table portal here, and then we open our Venn diagram. So let's double click on the Venn diagram as well. So the Venn diagram is here, the data table is here. Now, who are these two people? These are these two people. They're middle female, both salaries around this, and their spending is around this. We don't have information about history about them. That's why question marks. Okay, who are these people who are just part of the 16? So these are people who are just in group A, not in group B. These are people just in group B, not in group A. Now 32, if I want to see together, I can just press Control and select this. And the 18, if I see together, I can press Control and select this. So this is a very useful way of, you know, subquerying or, you know, breaking the data into smaller groups, and then using Venn diagrams to pick, like, you know, or look at the commonalities among the groups. And very soon this function would come into use in, like, while exploring with the data itself. So again, but before that, I'm gonna pause again a little bit to see if there is any confusion so far. Cool. If not, let's move forward. Now, in terms of exploring the data, there are a few other useful functions here. The next function is actually the imputation function. So what imputation does is it looks at the data and impute missing values. So let's look at that function here. We have imputation here, and say we connect the data. So first of all, the default method is not impute. So if I change this to, like, you know, I want to impute. So then I can choose either like the average or the most frequent data as a imputation, or we can choose like impute with random values, or we can use models to make some imputations or put in a distinct value, or we can also choose to remove instances with unknown values. So imputation comes into play when there are missing values. So interestingly, if we look at say the history, like if you look at the history of the data table, so if you look at the data table and just look at the history, if you see there are a lot of question marks here. These question marks mean that a lot of missing values in history. Another way to confirm this is if you look at history here, you'll see that there are 303 missing values. 30% of the data set is missing here. So we can impute these data. So to impute, we can choose different types of imputation. So first of all, what we can do is we can choose like, we can either impute using a model, that is model-based imputation, or we can impute based on say the most frequent value. So if we use a model to impute, we can choose like, so for example, for age, there is no like, specific value to impute. It's just history that we are imputing. So now after imputation, if you want to look at the feature statistics again, just to see what's happening to the, we look at the feature statistics and let's go to history. Now, if you see that it has used a model to impute the data in a way that there is zero missing. So now, so if we pick up something, let's say from the data here, let's pick up the data. Let's select the rows where say history is blank. Okay, they're not allowing me to pick that up. History is not, or not one of, let's say, yeah, there you go. So that would let me look at the missing histories. So if you look at the missing histories here, these are the ones where the history was missing. So, oh, sorry, it's matching data, so it should be, is not one of. Okay, is one of, then we can actually do one thing. Instead of matching data, we can double click this and let's say, let's collect the unmatched data. So these would give me history, which is, yeah, these are the missing histories. So now we can actually see that these missing histories are not there anymore after the imputation. So if I try to select rows here and do the exact same thing, which is like, history and then is one of, and then choose these. And then say, look at the data table and then say, okay, not the matching data, but the unmatched data. Here, if you see there is no data. Why? Because all the histories have been imputed. So this imputation, so if you look at this select rows, you'll see that, okay, high, low, and medium, all the 1000 isn't there. So this imputation is based on what we say a tree imputation. So they're using a model as a, like a simple tree, a decision-making tree or a recursive partitioning algorithm to identify the, like, missing histories out there. So for our case, the, like when we are using models, like using data to build models such as neural network, then missing data can create a lot of problems, in which case this imputation function comes into the hand. Now you can choose not to impute as well. Like for example, if there are some missing values in own home and you don't want to impute, you can just press don't impute here, in which case that column will not be imputed. Interestingly, if we do don't impute in history, you'll see something funny happening here. Then the unmatched data will show 303 data, which is the missing data. The moment I put in like no impute as a model, then it's going to get imputed and there will be no unmatched data here. So this is another useful function when we are trying to predict or trying to use fill in missing values. Now, after filling in these missing values, we can actually do one more thing, is we can save this data. So we can save the data and choose a place to save, like, we can save as somewhere and save the data. Because why am I saving the data? Because initially this data was having some missing data, which I've imputed, and now I'm saving the data. For now, I'll skip on this imputation because we can still work with the missing data so far. We'll impute later when we build on models. So that's another useful function, which is imputing. Now, few other functions of usefulness. One is the rank. So what do we do with the rank? If I connect the data here, so what it does is it ranks the data based on a simple idea, like, which ones have the highest amount of deviation. That's how it's ranking the data, fluctuation. So here you'll see that, okay, they have imputed some missing values and they have ranked the data in terms of like how much fluctuations the data has. Why is this important? Simple. If the data is not fluctuating, that means that the data is very constant across all customers, in which case it will be very hard to get insights. So that's where ranking comes into play. Ranking again uses like calculation, which is standard deviation. It calculates the standard deviation among columns to identify the columns which has the highest standard deviation. Now, similarly, we have the correlations. Correlations find out correlations within a data set. So here, a simple correlation table. So it's showing all combinations. So it's showing combination of amount spent with salary, which is a very high positive correlation. Then it's like, so which basically means that more the salary, more the spending amount, which I think is something we all could guess, right? In a supermarket, if you earn more, you'll spend more. Then you have number of catalogs. The more the advertising is done, the more the spending amount. Interestingly, more the salary, more the catalog, which is also understandable because I mean, if the shop finds out that you're earning a lot, it's naturally will try to advertise to you more to get you spending more. I'll skip the fourth one, which is last date of visit, because that's erroneous data. I mean, that's random data. So the last date of visits are not that important, but catalog, salary, and amount spent, these are correlated and quite positively correlated. I mean, this is a very strong positive correlation. This one, average positive correlation. This one is also moderate positive correlation. So quickly looking at correlations. Now, what else? We can actually look at a few other interesting stuff. So I'm gonna look at a few things more and then we're gonna pause. So the next thing is actually checking outliers. So let's actually clean this field a little bit. Let's actually move them a little up here to create some space. And let's find out these outliers. Identifying outliers. Okay, now there are actually few ways of finding out outliers. One is something a machine learning model called SVM, support vector machine. So we can use SVM to find out outliers. We can use covariance estimator, which is like how much fluctuation is being done, and then so the covariance estimator is actually a very easy statistical way to find out outliers. It just does is like for a data set, it finds out those data points which impact the overall covariance of the data set the most, and then picks out the top ones which impact the covariance a lot. So the idea is very simple if you think about it. So say you have spending of people, and let's say everyone spends 100, someone spends 10,000. So that 10,000 amount is going to increase the covariance of the whole data set a lot, right? That's an outlier data point. So covariance estimator is a statistical easy way to find out like, which are the points, data points, which create the most, like contribute the most to the covariance of the data set. Now, other than that, there is also isolation forest, which is again a forest or a random recursive partitioning way to find out an outlier. And there is also a local outlier factor. So the local outlier factor is the concept where we use the mean and the standard deviation to find out the outlier. The mean plus 2 standard deviation, anything beyond mean plus 3 standard deviation is considered an outlier. So the question is which one to use. The fun part is we can actually use all. And that's what exactly I'm trying to, I'll show you using the Venn diagrams. So let's say the local one is the most rudimentary one, and I'm going to skip on that. Let's say we predict a covariance estimator. And let's find out, say, 10% contamination. So contamination means like, identifying how many are outliers, like top 100. So here 10%. So we have the data set of 1,000. So 10% means 100. So we are telling Orange that there'll be 100 outliers. So instead of making it 10%, let's reduce it actually. Let's make it 5%. Let's identify the 50 outliers. So what's going to happen here is that if we look at the data table. So it asks me to which ones do you want to see, the outliers or the inliers. So I want to see the outliers. So this is the outlier. So let's say these are the outliers that Orange has identified using the covariance estimator. These are people either with very high spending or very low spending, or their behavior is not matching those of the rest of the crowd. Now, this is where the fun starts. So see, this is one way of finding outliers, which is we are using the covariance estimator. So let's rename it as cov outliers, which is covariance outliers. Then let's do similar stuff. Let's do another outlier. And this time we choose, we have done with covariance. Let's do SVM. And again, so here using SVM, they're saying that they're not being able to find any outliers. In that case, if I change the SVM, okay, so if I change the SVM coefficient, then being very strict or, using, so this new is what we say the penalty factor. Penalty factor means that, the lower the new, that means you'll pick up any small deviations from the overall data. So let's say if this means 70%, that means that, from the overall data, if any other data point is 70% different from the rest of the data, then you pick it up. So that's very relaxed. If I reduce the new to say 5% or 7%, this basically means that any data which is behaving a little like around 7% differently from other data sets. Now, how is this 7% calculated? This new parameter is one of the parameters of support vector machine, which figures out or which separates data. So 7% means that you're penalizing any data set or any data points which are even a little bit different from the normal data. So let's call it say 10% and see what happens. It gives me 32 outliers. So let's call it, let's rename it as, sorry about that, let's rename it as SVM. And let's create a data table out of that, which are the outliers. Now, besides that, let's do another outlier. And this time, instead of SVM, let's use isolation forest. And again, say I want to take the 5% extremes. And let's look at the data table here, which is the outliers here. Now, and let's call it forest outliers. We have 3 sets of outliers. The reason why am I doing this is because maybe, and this is where things become interesting with real life data, that in real life data, there's no golden standard on which is the best method of identifying outliers. Some data sets are organized in a way that curve outlier does the best job, whereas some data sets are convoluted enough that you need an SVM or a forest outlier. Sometimes, if the data set has a linear relationship going on, then it's SVM, which is better at finding out outliers. Whereas if you choose a data set which has partitionings going on, small subgroups within the data set, then forest outliers are a better choice. Now, I don't know that which one could be because the data set is still in a very exploratory stage. Our analysis is still in a very exploratory stage. So we don't know that which method is ideal for this data set. So in this case, when you're exploring, one easiest way to do is why not build a Venn diagram out of the 3 and pick the common ones? Because the logic here is that if a data point is an outlier, regardless of the method you're calculating, that means it is truly an outlier. It is behaving as an outlier in a way that every single model is picking that as an outlier. And the way to do so, very simple Venn diagram. So we pick up the Venn diagram here, we connect these data sets here, set 1, set 2, and set C, the third one. And we see that we do have 6 people out there who are, pretty much are the culprits. Oh, there is 968 in direct marketing second one. Let me check. Outliers. So this one has how many? Ooh, 968. Why is that? SVM. Let's check. Okay, so the kernel coefficient, if I reduce the kernel coefficient a little bit, 52 and 48, okay. So it shows that SVM is actually not being very much able to identify too many outliers. So let's do one thing. Maybe the data set is not ideal for SVM. So let's use the local outlier factor and then choose 50% contamination here as well. Yeah, I think that would be good enough. Now, if I look at the Venn diagram, zero commonalities. So if you're looking at three ways, let's increase the SVM's, local outliers. Let's make it 10%. And let's rename it as, say, local outlier factor. This one is the one which looks at the mean and plus minus the 3 standard deviation find out. We still don't have a common outlier here among the three methods, though from the COV outlier and the group C, which is the forest outlier, these 7 are common. Then again, between the COV hi, is there any question coming up? If you want to ask a question, feel free to unmute and ask as well. Cool. So there is a, between, say, local outlier and COV, there are 2 common. This puts us in a very interesting dilemma. This basically means that this data set is quite unique in terms of the fact that, the outlier methods are suggesting different types of outliers or different points who are outliers who do not have anything in common between them. In this case, so if it's a practical call, then I'll take so if this is in a real situation, instead of a hypothetical, say, now like a workshop, say if I was facing in a data set a problem like this, I would choose to do my analysis in 2 steps then. I'll create 2 data sets out of it. The first data set would be data that doesn't have these outliers, which is like this 2, 7, and 3. So I would pick up these 3 and then remove them from my data set and work with that. This would be my, I would say this is my conservative data set. Why conservative? Because these are data points which have been picked up as outliers by more than 2 methods. I will check the robustness of my analysis by taking a more aggressive approach of removing the outliers that are picked up individually by each of the methods, and carry out my analysis side by side for both these 2 data sets. One being very conservative in terms of picking outliers, one being very aggressive in terms of picking outliers. And see whichever gives me, if the results of my whole analysis is, consistent between the 2 groups. So this is another quite an extensive set of data preparations we can do with Orange. The last one I would show is actually there are 2 others. One of them I'll show you later when we're working with another data set. So another useful thing is the nearest neighbor algorithm. So when we bring in nearest neighbors, so what it does, it asks to find out who are the neighbors of a certain data set. So if you double click here, so if you drag here, you see that you need to give 2 inputs. One is the data and another is the reference. So here, for example, let's say we picked up very interesting people here, right? The data table here, which is like the medium income, high spend. Oh, these are the people who are, so we can actually pick up people who are both medium income, medium income, high spend, and who are female, close, high spend. These are the 2 people in here. So let's say from this data set, that is my whole data set, I want to find out the neighbors of these 2 people. So we are having an error pointed here, which is input data includes reference instances are excluded from the that's sure. So what it does is it tries to pick up these two people, and then from the data set tries to find out neighbors who are similar to these two people here. So when we look at the data table here, these are the neighbors. What do you mean by neighbors? So by Euclidean neighbor, the way they do it is they basically plot. So the way they calculate this is actually quite interesting. So what they do is here we have two data points in our data set, right? Now, in our data set, we have 11 columns, which means 11 dimensions. But imagine that you have a data set with two dimensions, x and y. So these 2 points would be 2 points in the xy axis, right? Using coordinate geometry, we can put them like an x point, like x1, y1, and x2, y2. Now, what the neighbors function does is tries to find out neighbors of the x1, y1 point and the x2, y2 point by comparing these 2 points within the data set among other people who could be plotted near them. So this is where the distance comes up, the Euclidean distance, which is the. So they try to minimize this distance to find out these 10 neighbors. These 10 people, if we plot the data in the 10 dimension space, the 10 columns we have, then these 10 people are closest to these two people we have identified who fall both among the common group between medium income high spend and female close high spend. So this is another useful way of exploring certain groups that, okay, you have this group, who are the people who behave similar to this group? And then you can identify them because these would help me identify who these people are and why they are similar. So for example, if I look at, say, own home, so see, a very interesting thing is medium income high spend or female close, right? So let's look at the location. So if you see that besides all the close people, there are some far people who behave very similar to the close people. So that's a very interesting insight. Then again, if we look at spending amount, so these are high spending people, but then some low spending people are having behaviors which is similar to the high spending people. So these are interesting insights we can investigate using the neighbors algorithm. This neighbors is done on Euclidean method. We can also do Manhattan distances, cosine distances, Pearson distances. So based on the choice of calculations you want. Frankly, if you ask me, Euclidean does a pretty good job because Euclidean means that you're just finding out the Pythagorean distance between the 2 points, but that does a good enough job to identify interesting neighbors. The last one of data exploration that I want to show in this in our session now is the overall process of something called pre-processing the data. So let's put in pre-processing here and let me show you what pre-processing does for you. It has a lot of steps actually, and it's pretty powerful. So pre-processing combines a lot of the things that we have here. So one is we can impute missing values, and here unfortunately when we're doing things like a lot of pre-processing together, they don't offer the tree imputation. If you want to do the tree imputation, you need to do it separately before the pre-processing. So suppose I want to find out the most frequent values in the history and then put the most frequent values in the history. So impute them like that. Then after imputing the data, we can decide to normalize the features. So normalize means that we can standardize the data. So I'll show you what normalization looks like. So we can decide to standardize between, say, for all numeric data, we will make the mean to be 0 and the standard deviation to be 1. So standard z-score, we compute the z-score from all the numeric data we have, or we could normalize it between intervals of 0, 1, -1, 1. So that standardization. Then we can also do some continuize or discretize. So discretize means any continuous variable we have, we can divide it into discretes. So we can divide into groups. On the other hand, we can also continuous discrete variables. So instead of having, say, male or female groups, or say close or far, or say high, medium, low, we can create a continuum out of them. We can create numeric values out of them, which becomes very important when we run neural networks. So let's say we create them as one feature per value. So I'll show you what this means. We can also make it like most frequent is base. Oh, let's make it one feature value. And the next thing we can do is let's keep on the principal component analyze for now. Let's just do these three and show you how our data set looks like. Let's draw the data here. It will look a little convoluted, but let's go through it first. So first of all, let's jump to the salary. If you see, the salary is divided, like, doesn't look like normal yearly salaries now. It's minus or plus, and these are all the Z scores if you think about it. So this number means that this person's salary was minus 0.49 times the mean plus, minus 0.49 times the standard deviation plus the mean. So that basically means that this person, person 207, whoever this person is, earns 0.5 standard deviation less than the average salary of the whole data set. Similarly, when we look at this catalogs, so this number means that this person has gotten 1.44 times the standard deviation of the average number of catalogs given to any customer. The amount spent of 4.8 means that this person spends 4.8 times standard deviation more than the average spending of the whole data set. So this is how we can standardize. Why standardize? We standardize data because otherwise salary was in thousands, catalog was in tens. Salary was in tens of thousands, catalogs was in tens, and amount spent was in thousands. So it would be hard to compare. This helps us compare. This is like apples to apples comparison compared to apples to oranges comparison. What else is being done here? If you look at this, say age middle, age old, age young. So we have actually created dummy variables. So this person was middle. So he gets a score of 100, which means that he's middle 1, old 0, young 0. Then again, this is 001, which is another dummy variable which shows that, okay, middle 0, this person is not middle, this person is not old, this person is young. So this same way, they have coded all the categorical variables into zeros and ones. So this is a fully numeric data set right now. How is it helpful? A fully numeric data set is required when we create our neural networks, when we create our machine learning models, because for machine learning models, we need to build we need to standardize the values and transform them so that we get the best predictions. But there is a problem with pre-processing as well. Pre-processing reduces the interpretability of the data. For example, now a single row can be very hard to interpret, which previously, if we were looking at just the data the way it was, would have been much easier to interpret. So pre-processing helps in improving prediction accuracy when we are building our prediction models, but it reduces interpretability. Now, one last pre-processing we will see, and which I haven't included initially, is the principal component analysis, PCA. So not sure if you have been exposed to the concept. So this is basically what we call dimensionality reduction. So by dimensionality reduction, we mean a data has many dimensions. So at this point, how many dimensions? If we have created this matrix, we have how many? 22 dimensions. Now the question is, oops, sorry about that. So the question is all 22 dimensions really important for my analysis? Maybe not. So then what principal component analysis does, it identifies the key principal components, but which could represent this 22 column data set into, say, a 2-3 column data set. By maximizing the variation of the data, so every data set, every rows in a data set is different, right? And since every row in a data set is different, there is a fluctuation in the data. There's a variation in the data. So principal component analysis plans to reduce the 22 columns into a small collection of columns, but keeping the variation in the data set intact. Why do this? At this point, it's just 1,000 rows. So the data set is a small data set. But when we have millions or zillions or petabytes of data, at that point, many columns can slow down my processing. In which case, if I can transform the data into smaller number of columns, but keeping the variation in the data set intact, then it is super helpful for me, because then I get a smaller amount, dimension of data to input in the machine learning models that I'm trying to train. So in this case, if I put in the principal component analysis, let's drag it down there. And let's call it, I don't want 10 components, I want 3 key components. In my variation in the dataset intact. Now let's see what do we get. 3 components here. PC1, PC2, PC3. My 22 column dataset has been converted into 3 columns only. Each of these PC1, PC2, and PC3 are transformed in a way that it has kept all these initial information intact. But it has transformed it to keep the variation intact, but to condense it into 3 columns. So this is a very powerful pre-processing system we have in Orange, which we can quickly make the data run through multiple steps and transform it for ready, like to make it ready for building prediction models. But a big word of warning is that if you can avoid pre-processing data and standardizing data as much as you can, stick with it. Because the moment your pre-processing is done, your original data is gone. You've transformed it, which means that any model output of this data, yes, it would be good at making predictions, very good at making predictions, but it might not be good at interpreting the outputs. So that's all the data pre-processing and preparing you can do. Oh, one last thing there is the feature constructor. It's basically creating a new column. So let's say, for example, from the data set, you want to create a new column. So you decide the name of the column, say you want to create a new numeric column, and let's call it, say, maybe spending per catalog. Spend per. And you create expression here. So first you select, say, amount spent, and then you select a function, or you can just, and then you select the number of catalogs, and you create a new column here. So when it's done, if you look at the data set, you'll see, sorry about that, you'll see a new column being created, which is spent per catalog. So that's how simply you can create a new column out of the existing columns. So that sort of summarizes what the data loading and preparations we can do in Orange before we start working with the data. So I'm gonna pause here and open the floor for any questions you have. What we are gonna do is, in the next session, we're gonna I'm gonna send this save file to you for, if you wanna reproduce this. In the next session, we're gonna look into visualizations, how we can explore the data with these visualizations, go in depth with some visualizations, and also look into some basic models that we can work with. And if we do have time after that, then we can actually see how Orange can help us work with texts as well. That's why I sent you a text data set. So I'm going to pause here today. We have already gone through quite a lot of functions, and I'm going to open the floor for questions. So if there is any questions, confusions, any need for suggestions, I'll be more than happy to answer. Anything, any confusions or any feedbacks of whether the session was a little too cramped, or it was hard to follow, because in which case I'll be more than happy to go over some of the stuff again and help you go through that. And tomorrow's session we can start with the visualizations. If not, then I'll pass the floor to Ria to like if there is any feedback from the team who's organizing, or else we can um, conclude today and move
Hello,
to the next
sir. It
session.
was a really nice session. And actually, I am not a very data analytics person, but still, I could understand a lot of the details you have shared. And I came to know that with simple mathematics steps, we can do a lot of data analytics. Thank you very much, sir.
Thank you
Am I
so much.
audible?
Yes, 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 you're audible. I can see
Yes.
some chat questions coming in. So, is data safe in Orange? That's a good question, Vituja. Uh, by safety, if you mean that is data safe in terms of like safe from prying eyes or hacking, I would say it's as safe as your computer system itself. If you're saying safe in terms of okay, if the or if like whether any changes or anything is being done properly or not, yes, because in the background it still uses Python to do these changes. So basically, Orange actually is nothing but using Python to do all these. So I think it's as safe as any other like methods you're using, because these are not done online, these are done in a computer. So it's as safe as you have kept your computer safe. I hope I could answer that. Darshana, you are asking, can this software be used in data analysis in healthcare? Of course. I mean, this software can be used in any data you have, as long as it's in CSV format, as long as it's a data like a SQL format or an like database. You can use it in any field you want.
Hello, sir. I
Yeah,
have
hi,
some
Ray.
questions. I have received some questions on WhatsApp. So
Yeah,
I'll just read one of them. It says, can we do sound analysis using Orange? Using Orange.
unfortunately, the sound has not been incorporated yet. The picture has been. So if you look at the add-ons or the widgets, you'll see that they have an image analytics added, but sound hasn't been added yet. So maybe if you could transform the sound into tabular format, then you can work on it. But the first transformation needs to be done with something else.
Thank you, sir. The next question is, can we do disease analysis with Orange?
I think as long as you have, like my question is very simple, like my answer is very similar to Darshana's question, that as long as you can get it in a tabular format, of course.
And so there's one request. Can you give one example on healthcare tomorrow?
Mm, I'm trying to get a data set on healthcare, but unfortunately, my expertise is mostly on the business side of it. So, which is where it's difficult. But I think what you can do is maybe this would be my suggestion to you, that maybe you can actually replicate the steps in a healthcare data set and say, I will share my contacts and everything with Ria, so that when you do replicate the steps in a healthcare data set, and if you are stuck or if you have any questions or if you want to show that, I'll be more than happy to give you pointers on that.
Thank you so much, sir. That's it.
Cool. Then shall we finish today's session, Ra?
Yes, sir, sure.
Cool.
Thank you so much, sir. I would like to extend my gratitude to our honorable speaker, Mr. Khan Mohammed Saqiful Alam, for taking out time from his busy schedule to grace the event and educating our students on data management through Orange. Thank you so much, sir. We will continue this workshop tomorrow at the same time, that is at 5:30 p.m. And this Mr. Khan will be performing some more applications on Orange, and we will get some more valuable insights on the advanced applications using this software. The feedback form will be posted in the chat section, so do fill out the details correctly as those will be reflected in your certificates. Only the students who fill the feedback forms for both the days get the certificate of completion for this hands-on workshop. So yes, do fill the feedback forms correctly. Now I would request Neelam ma'am or Geeta ma'am to give the vote of thanks. Ma'am, you there? Neelam ma'am, Geeta ma'am.
Yeah, I am here only. I thought I have given the feedback already. I have heard through the whole session, and I'm not, as I told you, I'm not a very data analytics person, but I am really interested in learning data analytics and into machine learning. So, as somebody was asking, I could not make out who was asking. We may be having data sets related to healthcare, like images or sounds, something like that. So we have to explore, still explore. So thank you very much for showing us there is a simple way of taking out the data set and analyzing it. As I told you, it was very uh, insightful to know that simple mathematics. I know we as the engineers know many of these things are based on the statistics, covariance, invariance, and all. But it was really helpful actually for us to know. Thank you very much for taking out your time. It is maybe late night for you. I know that you are to the east of us actually. Thank you
It's
very much.
perfectly fine. Thank you so much.
Thank you so much, ma'am. Now I'd like to welcome the president of BMC, Rutuja Jangam, for a thanking note.
Hello, sir. That was very interesting session and it was very informative. Am I audible, Ria?
Yes.
Yes, yes.
Yeah. So I really enjoyed the session because it was little topics which is there in our academy. Like good thing to. Thank you, sir, for the session.
You're most welcome.
All right. So I would like to thank all the participants once again for being so enthusiastic throughout the session. Thank you so much, and we'll see you tomorrow. Take care and stay safe.
Thank you. Bye, everyone.
Bye, sir. Thank you.
Thank you, sir. Bye, sir.